Our boat will be a 600-footer circa 1906 to 1911. Scale 3.27 equals 100 feet. Overall length 19.65 inches or 19 5/8 inches. Beam 2.125 inches or 2 1/8 inch. Now, here's how I really build my boats. The only really important measurements are the ones you see right here. Everything else is pretty much guesstimated. If something is off by an 1/8 or a 1/16 of an inch, sanding and wood filler will make up the difference. Now, if you didn't see the OCD video, here's a review. This is our motor, the Mabuchi RE14, also known as the RE140. It operates on 1 to 3 volts DC and is the perfect size for this type of boat. These are easily found on eBay or in a Google search. They are reliable and inexpensive. Similar but larger motors are the RE280 and the R3. Avoid the flat slot car motors. They're always trouble. Our task is fitting that motor into this stern. From my own experience, I'm telling you to plant it right here. We will build a flat bulkhead to attach to the bottom piece. This will force us to move the propeller from here to here. For hydrodynamics, we'll need to construct what I call a fade. This allows the water to smoothly reach the propeller. The motor's aft bushing will be anchored to this bulkhead. This means we'll be making some open space that we'll use later. Trust me. All of these measurements are interesting, but the fact is, the fade doesn't have to be all that precise. If you look at my fleet, they all have slightly different fades. What is important is that the overhang between the fantail and the motor bulkhead should be about 1 3/4 inches. Don't let this early chiseled fade worry you. I'll show you how to disguise it and to make it look really cool. The objective here is to make it workable but great looking. Our RE14 motor comes from the factory with this rust preventative coating that makes it look great, but we need to compromise it. We'll need to solder on it, and that coating can prevent a good connection. Enter the Dremel tool. These motors can make some electronic noise. In order to silence that, we'll need small disc capacitors. Any value will work. The capacitor blocks DC current, but passes AC current. Thus we want to allow the DC power to the motor, but we want to pass the noise, which is AC, to the motor case, rather than broadcasting it over our receiver. Here are the capacitors wound into the cross-silence configuration. Now it's time for soldering. Ta-da! Next, we'll do some ADHD measuring. Of course, that's my way, without numbers. First, take a sheet of plain paper. Using a straight edge, cut a strip about this thick. There we go. Remove any crookedness. Make sure you remember where the factory edge is, just in case your cut sucked. Now line the factory edge up with the end of the balsa piece you're going to mark. With your handy engineering pencil, make a small mark on the paper where the wood ends. Now, using the tiny 45 that you cut from an old CD case, line it up and make a vertical line. Take your trusty X-Acto knife and freehand cut along the line. Separate the piece, but save the rest of the strip. We'll use it a lot more. Now carefully fold the piece that you made exactly in half. Again, take your Mini 45 and draw a line down the crease. That represents the center point of the balsa piece. Now there are two ways you can use this measuring sliver to mark your center line. You can lay it out open like this, or you can keep it folded and just place one end at the edge of the wood and use the other edge to mark your center point. Normally I make at least 3 marks down the piece in case one mark is slightly off. Once you've made your marks, you can use your ruler to strike a keel line for your boat's bottom. Notice, no math was involved. Next, we need to find the center line of our motor. Now, if you don't have a fancy pair of dividers like I use, just use this easy method. Place the motor on a flat surface. Take a well-cut scrap of balsa wood. Bring it up against the motor shaft. Make a mark. Now take that same piece of wood and a sheet of paper. Transfer the mark like this. And you have a template that represents the exact diameter of your motor. Now we take that and set it at the edge of our bottom stock. Now take your strip of paper and measure off what distance remains. Mark that. Cut along the line. And fold that paper exactly in half. Without unfolding the piece, use it to mark inward from each outer edge of your bottom stock. Draw lines from those 2 marks up and out to where the fade begins. Next, cut on those lines. You've just perfectly centered your motor's location on the boat's foot. This, folks, is how my ADHD brain works. But wait, there's more. Here's how we make the sides of our fade. Believe it or not, a handy size for your fade walls is nearly the same as the width of your RE14 motor. So, no need to measure here. Simply cut a strip the same width of the template you just made for the motor, and you're in business. Next, take that strip and place it against the fade. Mark the end. A nip with the tip of your X-Acto blade serves as well as your pencil, especially if you've just lost the pencil in the confusion of all the stuff on your workbench. Cut that piece at the mark. Now use the piece you just made to measure out and mark an identical piece. Bingo, you have your fade walls. Okay, this just got longer than I expected, and I still have the motor install hacks to show you. I'm going to post another video with just those. If I kept them in here, it would stretch this out for more than 20 minutes. And it's hard to keep a YouTube audience for more than 6 minutes. From now on, the rest of this series will not be shot in HD. They'll all be shot in ADHD.